bonjour. And also hello to everybody on the web stream. So I'm Peter. First, I am going to make you guys all look at this beautiful picture of me, which was taken by my friend. That makes me look way better than I actually look. Let's all admit that. But I am a PM here at Algolia, and I focus on agentic in particular. Algolia has a couple of products in the agentic space. Within that, we have something called Agent Studio that helps you build agentic experiences, in particular with a focus on search and discovery experiences. So we'll talk about that, and we'll talk about how to build high quality agents. And that's why this talk is actually named Never Trust Your Agent, because we're going to talk about how do you know that the agent is doing the right thing. So let's first focus a little bit on what you might be doing and why you might be interested in this topic. So let's say you are trying to improve the search experience of your site. Until now, search experiences were pretty basic. They looked like this search bar. And then AI and LLMs came about, and suddenly something new happened. This AI mode button appeared on the right side, which made things much more exciting because it gave users a completely new way of searching. Yeah. So you might be working on a project to integrate what we call agentic search or conversational search into the existing search and discovery experience. This is a little video of something that you can build with Agent Studio. I'm going to comment on it while it's rolling. Let's see. So this is a store called Spencer & Williams that is our demo store, and I'm going to try an interesting query. Harry Potter themed presents for my 5-year-old cousin, I think. Yeah, there you go. And what happens now is after you submit that with this conversational search mode, the agent goes away. It searches through an index of products, and then it displays it in this carousel that you just saw right there. Right? So that's interesting because there's a couple of things that has changed in the typical way of searching. Before, users were effectively just typing in the input, and the search bar would send out an API request to Algolia and return a bunch of products that would display on the page. Now, with conversational or agentic search, that's a little bit different. The first thing that happens is you send this input, which was the Harry Potter themed present for a 5-year-old, to an LLM, right? And after that, the LLM has to decide to actually search through the index, which is done through something called a tool call. So tools enable agents to actually do stuff with the external world. In this case, it enables the LLM to decide to go to your index and try to retrieve items. Now, it might actually do that a couple of times. We don't know what happened in that video that I showed. It might be that it wrote the query in one way and then decided to rewrite the query a couple more times until it got relevant results, right? But let's say it's just going on the happy path. It searched once. And then those results go back to the LLM. And then the LLM can parse through the results, and based on the information in the results, it can pick which ones to show you. And that carousel that you showed, that was then showed to the end user, right? So that is a pretty simple chain of an agentic search experience that you can build with Agent Studio that results in the experience that we just saw in the video. So the next question is basically this big topic of evals. I don't know how much you guys heard about this, but its large point is effectively giving you a way to be able to optimize this agent's behavior. So you might have seen that, for example, it worked quite well for that Harry Potter query, but if you typed in something different, that may be a support-related question, you actually don't get the result that you want. So what do you do in that case? Well, you can do a couple of things, but you will need some sort of a data-driven way to evaluate that the agent is actually doing the right thing. And so that's what these evals are actually invented for. So an agentic eval is effectively a scientific process used to measure the performance of AI agents to execute multi-step tasks and achieving a goal as a result, right? So you saw that it was going through several steps until it displayed the result to the end user, and you're asking the question, is it doing that correctly? And for that, you need to set up a scientific process to evaluate if you're actually getting the result. This is why typically you need an eval. So to get that agent to answer to support questions correctly, you might change a couple of things. You might change from, say, using OpenAI models to using a Gemini model, because you might think or suspect that the agent didn't do a good job at actually retrieving the results or understanding the results that came back. You might actually think that something was wrong in the prompt that you wrote, right? And you go back and you change the prompt, you update it, you say, well, if you get a support question, why don't you check in this other data set and answer based on that? Maybe you want to change the tools that are available to the agent, right? So already you're seeing that there's an explosion of variables that basically lead to you needing a way to determine if the last change that you made to your agentic experience actually resulted in a better outcome for the end user. So to do this again, you will need data. But the problem is, how are you going to get this data, right? Well, you might say, I'm going to go test each query hand by hand. And every time I make a change to the prompt, I'm going to test one query and then make a change, go test it again, and so forth and so forth. But you know that LLMs in general, they can frequently, even to the same question, respond in different ways. So you already suspect that you'll need a lot of data to do this. And so because it's a lot of data, you're going to start to hit bottlenecks. Bottlenecks such as hand reviewing answers is hard. It just takes time. Even coming up with the right questions to ask is difficult, right? And you need a lot of this handmade work to evaluate the data in a way that it gives you a statistically conclusive result. So that's why you arrive at this next question. Can I use an automated system to help me with this work? Because you know that you cannot just make changes to the prompt of the agent or change the model without testing it. But you also know that if you have to do it by hand, you'll just never get through the task. So the next obvious question an engineer would ask is, well, can I use a machine to help me even generate this eval? So the next part of this talk is exactly about that. I will walk you guys through how we built a system that allows you to go from a given data set actually to a generated eval. So it makes it just as easy as pressing a button to make some change to your agent and then evaluate if the agent becomes better as a result of your change, right? So what do you have at the beginning of this exercise? Well, you have your data. So if you remember that Spencer and Williams demo, you had a bunch of products in there, right? So you certainly have that, and you don't need extra work for that, right? But you also have certain expectations, right? You have expectations, for example, for things such as relevance. So you expect that if you ask a certain question, when there's already a product in your data set that would be suitable to answer for that question, that product will show up in the answer, right? So you have these expectations. You might have other ones as well. For example, you don't want to talk about political topics. You might want to not put EM dashes because everybody knows that AI responds with EM dashes. Also, you might expect that you don't want to lie about the prices or discounts of the product, right? Things like that. So if you know these two things, you can already create a question based on it. So let's take a simple example with just one item. So we had the Harry Potter example. So here is a little toy that we have, which is like a puzzle or a Lego, right? And basically, you know that if someone asks for Harry Potter related puzzles, there is this item in the database. So if the agent doesn't find it, there's a problem. If the agent responds with it, it did a good job, right? So you can write this basic expectation, the agent should be able to find at least one product for a potential question related to this item. And you'll notice that this expectation is written in a generic way, right? We're not talking about the Harry Potter thing in particular. We're just saying, if there's this item, since we have it, if someone asks a question related to it, the agent should be able to find it. And that can generate a question if you use an LLM, because if you send this as a prompt, so you send the item together with this expectation, an AI system can actually generate a sample question for you. So in this case, it generated, find me a Harry Potter Lego under 300, right? And you know that this should result in a success if at least one item that matches this criteria is shown to the user, and you know that this is possible given your data set, okay? So now the next thing that you can do, once you have this one question and the expectation, is you can evaluate your agent based on this. So this is the same agent that we built that showed that demo working. It was actually showing you a set of Harry Potter themed toys to the user. And as you recall, after this person sent something, it went to the LLM. The LLM then went to the Algolia index. It retrieved all the relevant results, and then it highlighted some of them back to the user, right? And there's two potential outcomes when someone asks this question from this agent. It will either find an item that you know there's at least one item for, or it will say, I couldn't find an item, right? And depending on this, let's say if you went with, you changed the model to GPT-5.4, you actually found the relevant item, and now you change this one variable, which is the model, to Gemini Flash, and suddenly the system responded, I couldn't find the relevant item. So you know that on this one case, OpenAI did better than Gemini, right? So you can record these answers as a 1 next to GPT-5.4 and as a 0 next to Gemini Flash. So on one question, on that one, you've now used a completely automated system to generate a question based on a single item in the database, and then evaluate the response by another LLM to see if it was correct or not, because you knew what the correct answer would be. So now imagine you actually do this on 1,000 questions, right? So you randomly select 1,000 different toys or items from the database, and you generate these questions the same way that we did. And then every time you score a 1 or a 0 depending on what you get back. Now you actually can get to statistical significance and determine if on 1,000 questions GPT-5.4 did better than Gemini Flash 2.5, right? So that's how we get on relevance now a statistically significant result that GPT-5.4 is actually better than Gemini Flash. But you can then add other criteria and other questions. So you can just add more columns. You can pick a particular criteria, such as, for example, check some detail inside the product, like the price, and then the AI will generate a question about that. You can also look at how quickly the models respond. So you can start measuring more and more things. And you can also start measuring different models. And so as you do this, you end up basically building this table, and the outcome of this table will be very interesting, because suddenly you can basically take every single model that's publicly available today in the world and compare them against each other, which one actually does better on this type of e-commerce tasks that is so prevalent for most of the commerce world if you're working on it, right? So this table is what we're going to see in a second. I'm going to open it. Now it is publicly available as well. You can go to algolia.com/LLM leaderboard. And here is where our team, the research team, publishes results. Whenever there's a new model that comes out by a frontier model lab, we actually go and evaluate across a bunch of important criteria how these models are doing, because one of the top questions that we get from customers who are trying to build agentic search and discovery experiences is actually, which model should I use for my website, right? And so now the customer can answer this. So let's go there. So this is what it looks like. It was, of course, made by AI as well. That's why it looks so good. So here is the results. So we actually measured models across 3 quality criteria: relevance, hallucinations, and language. So we talked about relevance. Hallucinations, again, is if there's a discount or a price, can it pick out the right thing or some other detail correctly? Or does it invent things? And then the third column here is about language. This is whether the model actually responds in the question, to the question in the language that the user asks it, rather than responding in the language that the data is in, right? So if your data is in English and someone comes in and asks you a question in French, you want the model to still respond in French, right? So then this quality column is basically an average of these 3, but you don't have to look at this particular column. You can sort by each one. And then we also added speed and cost. Speed here actually measures when you saw that last response. So it's thinking, it's doing things, it's searching, and then suddenly it starts streaming, outputting a response. So the very first character, how long does it take to get to that first character? And then on the cost, we took public costs that you can get from providers like OpenRouter and summed it up based on the tokens that the model is using. And so you can see that there's actually quite interesting difference in model behavior. So across relevance, we see that there's a big gap between, for example, Grok 4.1 fast non-reasoning here is coming out at 68 only, versus some of our top models like GPT-5.4 thinking low, or GPT-5.4 here, or Claude Opus 4.6 actually come in at almost a perfect score. On hallucinations, there's again quite a divergence, and on language, there's quite a divergence. But I think one of the most interesting things is the speed differences. You can see that these actually really matter for UI. You'll find that probably waiting for 15 seconds on an average response is going to be not very great for user experience. And also the cost is tremendously different. Some of these have 35, 40x difference in cost. And these, of course, can balloon when you think about your LLM costs. If you were to switch from Algolia Search to always using AI to respond, that would make a completely non-starter business case, for example, right? So you have to be very, very careful when you're selecting to pick something that gives you the right trade-off between how quickly the model responds, how good the quality is, and how much it costs. So that's what you can do. This is now, again, publicly available on Algolia's website under algolia.com/LLM leaderboard. We also are working on allowing customers to generate these evals that are going to be custom for their own data set. This was based on that Spencer and Williams fake data set that you saw. But we think there might be differences depending on what industry you are in and what kind of data you actually have. You might get different results. So that's one of the next steps for us. But that was basically the talk. I believe that now we're going to have a Q&A session. Is that right, Daya?
That's exactly right. Thank you for this talk, Peter. We have time for a few questions, and we have a trend here in the questions. Let me just ask you the first one. How often do you need to regenerate these new questions, like this new process, as your data set evolves?
Yeah, so that's going to be highly dependent on how much the drift in your data set will be. Ultimately, in a typical e-commerce scenario, you're probably good to generate it once and then rerun the eval on just the variations of the agent. You don't need to generate the questions so frequently. That would be my recommendation.
And it's a kind of a similar question, but more framed and catered to the models as they also themselves evolve, and new models are released like kind of every day now. Do you see a need or a way for this LLM leaderboard to kind of be regenerated and like track the trends of those changes?
I think so. If you look back even here to the 4 series models from GPT, which hasn't been that long ago, there's a pretty significant gap, right? So you might be thinking of some of these things like hallucinations as a larger problem and you're building custom solutions for them, but we can see that the market is actually improving on its own. And frequently the models end up solving the problems for you that you invest development time in solving. We also know that the market is quite competitive and the prices are shifting all the time. There's also a lot of open source models coming up, and you can also do things like fine-tuned models if you're a large enough customer that has resources for that. Agent Studio, of course, supports all of these models. You can plug in whatever you want, and this is one of our core tenets that we don't want you to be locked in, because the market is moving so fast. At any point, there can be a new model that will be significantly better for your end users.
Thank you, Peter. One questions going back to the actually to the questions. How many questions are required to get a reliable set of results? And would manually reviewing the questions, but by a human in the loop who knows the business well, make the results better?
So we did a lot of manual review to arrive at the questions being good, but the generation strategy being good, not the final questions. So in this case, we have close to 1,600 test cases, and that gets you on the CIs about, so you can see here when you hover, it says 94.8 from 92 to 97. So you can measure about a 5-point precision at a 95% confidence interval. Basically what that means is that some of these models, and this is why you'll see that they're marked as equal 1, equal 1, equal 1, equal 1, they're indistinguishable from a statistical standpoint. Now, the more of these cases you generate, the smaller that confidence interval becomes, which means that you can make better distinctions. But we don't think the purpose of this particular eval is to have absolute certainty on every single question. It's rather a guide for you to understand roughly how these models perform. And then from there, it makes sense for you to move on your custom data set and evaluate with your custom data. You'll get more value from that than trying to generate more questions on a random data set. And of course, at some point, you have to race to actually backtest it on your real queries that users are asking. Because you have to remember that these types of offline tests, they run a big risk of you don't know if these are real questions. And frequently, the questions you are evaluating aren't actually representative of what end users are asking. So the end state should be, I have a constant stream of real user queries coming in, and I can eval on these real user queries with my real data to make sure that I'm improving the real experience on the site.
All right. Do we have time for one last question? Okay. Focusing back on Agent Studio itself, why would I use Agent Studio? A question from Gaz. Why would I use Agent Studio in preference to giving my LLM direct access to my data? What would you say is its USP? Unique selling point. Thank you. Peter has mentioned, you mentioned more control, but we are used to Algolia being fast. Is Agent Studio speed something to brag about too?
So let's look at the data here, right? First, starting with the speed question. The reality is that if you look at basically where the time goes, say, in these roughly 10 seconds that it takes an average model to respond based on this column, it might be doing a bunch of things. It might be thinking, streaming tokens to figure out what to do. It might then be making consecutive search calls to retrieve, and ultimately spitting back an answer to the end user. So some of that speed, Algolia doesn't really have control over, right? We don't have control over, for example, are you queued? This model is really, really popular. everybody has to wait to even it start to get streaming, right? Also, the size of the model is going to, and the tokens that you send to it significantly impact the speed. But this problem of how much the model has to search through the space and how quickly it ends up finding relevant information, Algolia actually has direct sort of impact on. So the better Algolia's search is, the better the agent will find stuff. And that will actually resolve in the user seeing a response much quicker, right? So that's why for us as a company, we're now not only focused on building end user search, but also focused on agentic search, which is actually a product that we fine tune to how agents interact with a search interface, right? And there's a bunch of interesting tricks that we perform to optimize how well the agent can use our search system to get the most relevant answers as quickly as possible. That's one thing. Now, you can take, for example, our MCP, and you can build your own agentic system and just plug in Algolia search in there, and you will still get the benefit of how well Algolia search works. But you'll face a ton of other interesting problems along the way, which is, how do I build the UI correctly? What kind of components should I integrate into my website that makes sense for the end user to interact with this natively? How do I track everything that the end users are doing and get analytics? How do I optimize this stuff? How do I configure my merchandising rules and allow my merchandising team to also configure things inside the agent? And this problem is the problem that ends up ballooning, right? It was the same basically with search as well. Lots of people 10 years ago, now nobody does this anymore, wanted to build their own search because it was the hot topic, right? And then they realized that there's a lot of management stuff you have to build around it to actually get a good product, besides the fact that search is also difficult to build. And so those things are also important for you to run an effective business. It's not just about rolling out some MVP that looks and kind of works good, but it's about tracking what's happening and being able to optimize it over time easily so you get business value out of it.
Thank you so much once again. It's working, okay. Thank you so much. Once again, Peter from Algolia, Staff Product Manager for Agent Studio. Don't forget that if you create an account with Algolia, you get a free tier with access to the Agent Studio in beta right now.
Yeah, that's right. And actually, Agent Studio is also free. So how do we make money? Nobody knows, but come and try it. Thank you so much. Appreciate your time. And thank you, Daya.
All right, give a round of applause to Peter. Thank you again.